actually talk a little bit about something that looks like this one. Things to think about. If I'm looking at the ln of x, right? What should go through my mind when I'm looking at the ln of x?
It's 1 over x.
Yeah.
Derivative is 1 over x, right? So the derivative, can I integrate? No. So it's going to have to be my u. Very good, right? And will anything ever get to 0?
For what? Well, the square root of x. If you bring that to the top, you have x to the negative 1.
Yeah, but when you subtract 1,
Oh, right.
you're going to get...
And you're just going to keep going to a lower infinite number.
But never 0.
Yeah.
Right? So, okay, so we're going to have to use the old-fashioned way, not tabular method.
Yeah.
Okay, so I know, would you guys agree that this could also be written as x to the negative 1/2 ln of x dx?
Mm-hmm.
Does that make sense to all?
Yes.
Okay, so I know I have to have a u, I have to have a du, I have to have a dv, and a v. Because the formula is uv minus the integral of v du. Everybody good? All right. U is ln of x. Du is 1 over x dx. Okay. dv is x to the negative 1/2 dx. And its integral. Add one whole and put it over itself. So x to the 1/2 over 1/2, which is really like multiplying by
2.
2. Right.
That looks a lot nicer.
Questions, comments, concerns, issues?
Not so far.
No? Good. Okay. So, UV. So, UV. So, 2x to the 1/2 ln of x minus integral of v 2x to the 1/2 du 1 over x dx.
Wait, is that UV? Is that a formula on the spreadsheet?
It is written a little differently than the way that I say it. But yes, it is on the bright colored sheet of paper. Okay? So, the stuff here, ugly as it is, just kind of goes for the ride. Is that good? This over here I need to clean up a little bit. The things that I think would be most beneficial is the 2 can come to the front. I don't really need that 2, so it's coming up here. And then if I have x to the 1/2 times 1 over x, I really have x to the 1/2 over x to the 1. So what do I have?
X to the negative 1/2.
I have x to the negative 1/2. So far, so good? Everybody on target here? Okay, so this again is just going to kind of go for the ride. Ugly as it is. The 2 minus 2 goes for the ride. Can I integrate x to the negative 1/2?
Yes.
Sure. So let's go for it. So I have x to the
1/2.
positive 1/2, right, over
1/2.
1/2, which is really like flipping it up
Right.
and making this a 4. Would you agree?
Yep.
Plus C, smiley face, all done. Not smiley face, all done. Why? Because it has an A and a B. Psych. From 1 to 2. When you thought you were done, you knew you weren't.
When you're asking, you get that.
Got excited?
Your quote.
Just when you, yeah, in math.
You were done and you weren't.
Because it doesn't, are you kidding? You're never done. So you're going to plug in 9 all the way across, right? So what I did there was a great example of how you can fix your issue when you have an A and a B and you put a C by mistake, right? So learning lessons, very good. So we have 2x to the, next, instead of x, we're going to put 9.
You put 3 because it's just 1.
Well, yeah, you're good there. So, yeah, I would do the same thing, but then people go, where'd you get the 3? So I'm trying to slow down this year. Doing the best I can at it. Minus ln of 9, and then minus 4, 9 to the 1/2. Minus parenthesis. Why the parenthesis, you ask? Because that minus has to distribute all the way through. Okay?
make everything a little less.
Okay, so we're going to plug in, so 2, 1 to the 1/2, ln of 1, which we should know, minus 4 times 1 to the 1/2. What is ln of 1, by the way? I've shown you the graph a few times.
0.
Yeah.
Yep.
Yeah, ln of 1 is 0. We know that because remember I showed you that pretty graph. And, okay,
And
so
then ln of 9 is a
it's a number. We're not going to make, there's no discrimination in this class. ln of 9 is just as beautiful as 9.
That's okay.
Yes.
So if you had ln of 9, do you take the ln of 9 and
Leave it ugly.
leave? Okay.
Sorry, I call it ugly. Leave it ugly. So we have 9 to the 1/2, we know is 3. 3 times 2 is 6, ln of 9.
Can we just leave it?
Yeah. If you want to get fancy, you can put the 6 up there and put 9 to the 6. Don't worry about it. Minus 9 to the 1/2 is 3. 3 times 4 is 12. Are we okay? Oh, all this junk becomes 0, right? Because ln of 1 is 0. Anything times 0 is 0. 2 negatives make a positive, so plus 4. Clean her up a little bit. So you have 6 ln of 9 minus 8. It's really not bad. You were able to follow it with some comfort level? Not bad. Okay, so I'm going to get an old test.
You just want us to leave ln 9.
Yeah. A lot of times what they'll do is they'll say, make this, show that this is that. And they'll tell you the answer they need you to get at the end. So that's typically what, yeah. So part I will be, show that this is this. 4 points. Okay? So actually,
So it's exactly like the trigonometric function.
a lot like it. They'll tell you the answer. They'll give you the answer so you can know which direction you need to end in. Yes?
Well, this is the exact same as like when we found the area under the curve.
Well, you know what? That's interesting because this morning I had to sub for a class and I'm sitting there going, well, I want to pick out a few problems that I think will, and every single one of them were like, you have to do a derivative of this junk, but then the next step would be, and find the area under the curve of it, which is the same thing as what we've been doing, right? On the test, obviously, we're not going to find the area under a curve yet. I'm not going to call it that because we haven't really practiced it in that manner, but truly it's going to be, make this look like this, actually take its integral. Okay, so while you wait, I'm going to pull some up and we're going to work on them. Because I told you guys, test is when? Thursday.
And then someone goes and tells EJ and he calls you during second period about it.
I didn't want to talk to him about it. No, because that means
For Easter, you just say, I dip myself in dye.
I'm a candy corn egg.
There you go.
Okay, so look at this. Back in the day, October, November 2002. Remember, that was yesteryear, but they're worth 4 points, okay? So here's the deal. If we look at it, find the exact value from 1 to 2, A to B, no C, of x, ln of x.
We can do that.
What should your mind automatically think?
By part.
I'm going to do integration by parts.
Yeah.
Oh, can I?
No. Well, you can't do the tabular method
I
because
can't use the tabular method. That's where my brain was. I can't use the tabular method because of the ln of x, right? But it's okay. We're good. We know how to do this now. So, good. We're going to do it, but just look I want to scroll through so you have a feeling of what these tests look like. Okay? Look at number 2. And these are singleton questions. There's no part I or II that went along with this. Back in 2002, remember this was a long time ago though. Okay?
It
So
was supposed to be really, really hard to do all this stuff. Now this is the simple stuff.
Back when they
We're
didn't
only
make
going to
this
get harder.
difference.
I just want to build on it a bit and show you, So here we are. Find the exact value of this. Doable? Once again, A to B, no C. We can do that.
No problem.
They didn't give you an answer, though. They didn't tell you this is what it should look like at the end, like I kind of just told you. All right, so that was 2002. Let's keep scrolling for a moment. Okay. Look at this one. Okay.
Gives you the answer. And they took a point off.
I mean, that's not all that.
That's an II.
It's just a lot of fractions.
It's a lot of fractions going on.
That's
From
a
First you
yeah.
prove it,
Just go through this.
First, you're proving an identity that cotan minus cotan of 2x, which we haven't learned yet,
And then
is equal to that.
And then you're
Okay.
essentially
No crap, no. We're good. I'm going to show you how to do it. But what's another way to think about this problem? The minute I saw this, had I not seen this identity, I would have thought something different. I would have thought, what do I know about cotangent?
It's the same as cosine over sine.
It is the same as cosine over sine. Let's look at that for a minute. It's the same, would everybody agree, as cosine over sine? Oh, you good?
Yeah.
Okay. Second thing I do is say, oh, it's a fraction. What should I automatically try to rule out if it's
Du over u.
Is it a du over u situation? Well, let's see. If this is u, what's its derivative?
Cosine, negative cosine.
Yeah, it's regular
It's
cosine.
just regular cosine.
Yeah.
This is going to mess people up with these positive negatives.
That's
So this is
crazy.
a du over u situation.
Mm-hmm.
That's pretty cool. So if it's a du over u situation, how do I handle that? What is the integral of a du over u? It's the ln of sine. Okay, so it's the ln of sine, et cetera, et cetera, et cetera.
Also,
Okay.
L out of sine is
Right. So think about that. But they did this for a purpose. So we may have to utilize this because remember when it's an I and an II, there's multiple ways to get to where we need to get. So keep that in mind. But sometimes if they just show something like that, maybe we can utilize that topic. Okay, yes.
Is it always the ln of the thing on the bottom, or is it just ln of
Yeah,
sine?
yeah. It's always the ln of thing on the bottom if you have du over u. Okay, let's keep working here. So that was 2000 and whatever.
On Wednesday, can we go through, like I know that you told us to like brainstorm it.
Yeah, let's go through it. And make sure we get it. Yeah, I want to do that. So the way you could say, you know, if I see this, maybe I should do this. If I see this, I should do that.
I can bring it up this week.
That'd be great. And then we can create it. That'd be perfect.
brainstorm thing on the board, and then everyone will say, what about this step and this step?
And then we'll create our poster board. Okay, so now look at this guy up here. It's just for the fun. The diagram shows y equals 3 minus x e to the negative 2x, and its minimum is at m. Way back in the day, last year, I taught you how to find max and min.
Mm-hmm.
Does anybody remember the topic? How do you do that? Yeah?
Take the derivative, set it to 0, solve for x, plug x back into the original, and solve for y.
Let's do that.
That's
So,
why I should have paid attention last time.
That's why I should have paid attention.
so this first thing here said calculate the coordinate of m. So what would we have to do with this?
Take its derivative.
Take its derivative. The reason why I wanted to talk a little bit about this is on this test we're practicing derivatives and integrals. Not like applying them, but just doing them kind of deal. So if I'm looking at this, think about what we've learned this last couple weeks. This would utilize the techniques that we've learned this last couple weeks. We should know how to take a derivative of this.
That's a
You'd
change.
have to use product rule. Okay? Let's do it.
Derivative of the first
Yes.
times the second.
Yes.
Times the third step,
Refresh times the 13.
multiply by the seventh,
Then square it.
and then cube it. And then you look on the unit circle, and x equals 4.
You were so close. Okay, so the first thing we have to do is recognize that there are two separate entities altogether, right? 3 minus x, and then e to the negative 2x. Would you agree? Okay, so the first thing we're going to do is take the derivative of the first times the original second. So what is the derivative of the first?
We use chain rule.
Negative 1.
Well, it's just the derivative. There's no exponent here other than 1, so we don't have to use chain rule.
Right.
So it's negative 1, right? So negative 1, and then times e to the negative 2x.
Which is,
It done.
Negative e.
So plus the first, leave it alone, times the derivative of the second.
Oh, it's a
e negative.
plus in between.
Yeah.
Yeah,
So
product
for product is addition, for quotient is subtraction.
Which
Order
makes
doesn't
sense.
really matter, it's what you derivative of
Correct.
one times.
Right.
Okay.
And then
So-
it's EU du, right?
It's EU du. So you're just going to rewrite e to the negative 2x, and then what's the derivative of the negative 2x? Negative 2. So would you guys agree instead of plus here, I should put like minus 2? Yeah. Okay. So would you be comfortable if on the test on Thursday you were given a problem that looked like this, and I told you to differentiate?
Mm-hmm.
Okay, that's kind of where we're at. This chapter, this particular unit that we're doing is gearing us up to be able to find the max and min, be able to, you know, find the area under a curve.
I'm really happy we're doing this now because I have to take the retake soon.
Ah, that's a good review.
Yes.
This,
Which is fantastic because I have to take the probability and statistics, which is the one that I failed last time on my birthday.
Oh, I'm sorry.
You need 20 practice.
Talk a little bit about this problem. This is number 10 from back in 2004. Look how big it is. It's an 11-point problem. Okay. The first said, write down the x-coordinate of A. So we know that it crosses the x-axis when y is 0, so you set this equal to 0 and solve, right? So you can go through that process. Alrighty. I think that would be easy enough. Worth a point for a reason. Find the exact coordinates of M. So M is, do you guys recognize that M is a maximum? So let's talk a little bit, how do we find a maximum? Well, we have to take the derivative. Good, close, close, very close. Take the derivative.
Yep, plug it in.
Set it to 0, solve for
Set it
x,
to
plug
0.
x back in the original, solve for y.
So you take the derivative of it, you set it to 0, you solve for your x, you plug it back in, and you find your
So
y.
wait, what's the difference in the max and min?
They are both stationary points. The technique to find them is the same thing.
Is it?
Yes.
Can we do that?
We're going to do it. Yeah, of course.
Okay, as
Yeah.
a refresher for how to like isolate. If you set that
Do you
equal
want?
to 0.
Do you want me to do all that?
I
Okay.
would like to.
Okay, let's do it.
Miss K?
Yeah.
And when you have to use the second derivative in order to find whether it's the max or the min,
But
because
they
you
tell you. They
Yeah.
tell you it's a maximum point, so you don't have to worry about it. But yes, there's
Yeah.
something called the second derivative test, which, review, for people that need this, if the second derivative test, the way it works is you take the first derivative, and you find its critical points. So, as Nick's been telling us, you take the derivative, you set it to 0, you solve for x, right? The second derivative, take the second derivative, plug those values you just found, plug them in. If it's positive, that means it's up like a cup, which means it's the minimum. If it's negative, it's down like a frown, which means it's a maximum. Okay, so that's a bit of a review for those of you that are retaking. So we have y is equal to the ln of x over x squared. Okay, that's why I think this particular class is a little easier than last. You have so many new things to learn. Now you're utilizing it, if it makes sense. You're trying to pull it together and kind of see. Well, that's why we review. That's why we go through the process of learning a little, but doing lots of review. Okay, so we have the ln of x over x squared. First of all, write down the x coordinate, so where it meets. So you guys told me that you know where this is 0 is where my a is going to happen. So what's the first thing? Multiply both sides by
x squared.
So multiply both sides by x squared. So I have ln of x equals 0.
That was easy to know.
What is it?
1.
1. Because why? ln of 1 is 0. What's an easy way to figure out that is? If I can't remember that, here's what it looks like. So I have ln of x equals 0. There's a little itty bitty subscript thing that goes between the ln and the x, and what is it? E. So I'm going to write it here. If it's not there, it's because it's assumed there. So it's e to this power is going to be the value that we're looking for. Talked about that at the beginning. So e to the 0, 1, my value of x is 1. Okay? 1 point, easy enough. So the ordered pair here is 1, 0. Are we cool? Okay, next part says, write down the exact coordinates of m. Okay, so it wants me to be able to take the derivative of this thing. Let's talk out loud for a few minutes. It's written as a fraction, so I have to use the
Quotient rule.
That's right. So for me to find y prime,
Low D high minus high D low over low low.
X negative squared.
Can I read x?
you can, x to the negative 2.
Yeah, because then
X negative
Then you
squared.
can
It
use
just
product
sounded
rule.
funny. It just
because
sounded
it's not
really
like a
funny.
big thing.
It's up to you. You guys do it, you'll get it both the same thing. My personal preference is low D high minus high D low over low low. So it's low, what's D high?
1 over x.
Yep. Minus high
ln of x.
D low,
2x.
all over,
X to the 4th.
perfect. Now, write down the exact values of m. For us to be able to find the exact values of m is where the first derivative is equal to 0. You guys with me there? So what we're going to do now is recognize anytime I have a fraction set to 0, the denominator goes away. Do you guys agree? So I really only care about this first top part set to 0. So I'm going to clean her up a little bit like this. X squared divided by x is just x minus the natural log of x times 2x. And that's going to be set to 0. Why? Where did the x to the fourth go? I multiplied both sides by it, basically. Okay. Now, the next thing that I do is recognize that I have something in common that can factor out. On either side of that subtraction, the x, that's right. So I'm going to factor out the x. I'm left with 1 minus the ln of x with a 2. I'm just going to put it out front, equals 0. Is everybody okay? The first one is x equals 0. Is that possible? Can my x be 0 for my maximum point?
No.
Look at your picture. X is 0. Definitely not
Nope.
here. So that's not your option. Everybody okay? So the option that's going to have to work is when this guy is. So I'm going to take 1 minus 2 ln of x and set it to 0.
And salt.
Say it again.
Salt.
It's our salt, right. So I'm going to add 2 ln of x to both sides. Divide by 2. Everybody okay? Divide by 2. And I told you a really easy way to find that value of x. E to the 1/2. That's exactly right. So little e that we don't see raised to this power is going to give you the value of x. So e to the 1/2.
Which is 1.64872.
1.64. What?
Or just 1.65.
Okay, 1.65, right?
Yeah.
And it actually asked for the exact coordinates with an S. That indicates I need an ordered
Put
pair.
that back in the original.
Plug it back in the original.
So
So 1.6.
Wait, what do you mean? I'm talking to myself.
Oh, okay. So I have 1.65 for x, plug it in here. ln of 1.65 divided by 1.65 squared. That's your y value. Write it as an ordered pair, you get 5 points. Yes?
So they want the actual numbers, not like, you wouldn't leave it as
Well, it
square
says
root.
exact value. You know, that's a really good
X
question.
value would be square root of E.
Thank you.
Yeah,
That's
you know
if
what?
plug in square root of E, you get
Yeah,
something.
you know what? They don't, okay, sorry, I apologize. Exact value means they don't want decimals. No, no. So let's go back.
E to the 1/2.
E to the 1/2.
So we plug that in.
So our ordered pair would be e to the 1/2, comma, whatever it turns out to be when we plug it in. So of ln of e to the 1/2. Oh, let's look at that. Yeah, can you guys remember why?
The backwards ln of x means e cancel out.
Right, because it's ln of e to the 1/2 over e to the 1/2 squared, right? Okay.
1/2.
Yeah, because remember when the L and the E are touching, I tell you they disappear. It's just an old trick. So, and then e to the 1/2 squared is e,
Wait, where's the magic?
so it's 1 over 2e. What?
What was the magic?
LNE.
Well, okay, so let's look at it this way. There's a
Only
little
cancels
e
it out.
here. E to what is e to the 1/2? Well, it's 1/2. And this, I heard it in the audience. I heard it.
1 over 2e.
1 over 2e is what I would be looking for.
What if you did, okay, so 2 is getting divided by E. Like, where is it?
It's 1/2 is getting divided by e over 1. So you take the e over 1 and you flip and multiply.
I was looking at
All right, are we good so far? Okay, so that was 5 points. To me, a doable 5 points. The next one, use integration by parts. Well, aren't they nice?
Yeah, right.
Use integration by parts to find the exact area of the shaded region enclosed by the curve, the x-axis, and the line x equals e. So let's set it up so what it looks like.
This is when I wish that I was born like 10 years earlier.
Why?
Because these just seem simpler. Life was simple back then.
Yeah, 2004.
I mean, I really couldn't. I
I think
think
you're going to find these are very similar to 2014 and 15.
There's really no difference.
No.
Back in the day.
They can't make these any more difficult or less difficult. The concept is the concept. So,
I think just
well, you
like
saw
what you
in
heard
2002, you saw they were pretty simplistic.
Mhm.
These are very, very similar to what you'll see. Okay? So let's go ahead and look at this. It says, use integration by parts to find the exact value of the shaded region. So it's going to be from here to here. So what are my A and my B in this particular case?
1,
1,
and then
1 to
E.
1 to E, right?
Yeah.
Okay. Do you guys know why it's 1? Remember we found we saw for A for part, right?
That was part I.
Part I, yeah. Yes.
Don't you put 1 on top and E on the bottom, or
Left to right, bottom to top.
left to right? Bottom?
So left is 1, E. So left to right, bottom to top. Because it goes from smaller to bigger. If you can make sense of it. Smaller is 1, and that's like 2.7-ish.
Or bigger to smaller?
Well, however you
Bigger
want to
to
look at it.
smaller,
You do that. I don't know. Okay, and then it says integration by parts. So I have the ln of x over x squared. I'm going to put a dx attached to it. Hey,
Every week, I want to come.
integration by parts. Things that should go through my head. Yeah.
Why do you sideways on our paper? I have so much space
She
left.
knows that's good.
Yeah,
It's
hold on,
perfect. I would rewrite this. That's funny. I would rewrite it to look like that. So I visually can say, what am I going to call u? What am I going to call du? Blah, 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 blah. Well, what do I know about ln of x?
You can't integrate
I
it.
can't integrate it, so it has to be my u. Therefore, I can't use tabular method. Of course I can't.
It's the anti-tabular method?
Anti. So
Anything
u
with
is the ln of x.
Anything with L of N does not. You can't do
You
calculus.
can't integrate it, so you
Okay.
have to go ahead and use it as your u.
And it never gets to 0, so.
Right, so you have to go this route. Okay, so the first thing is, what is the derivative of ln of x? 1 over x. Beautiful. 1 over x dx, if I'm going to be precise. And then, what is the integral of x to the negative 2?
Negative x to the negative 1. Or,
Yeah, x
Yeah.
to the negative 1 over negative 1, yeah. Are we good?
mhm.
Okay. So remember, it's the formula that's on your bright color sheet of paper. Just give it to you a little differently. It's uv minus integral v du. I always go like this: uv minus integral v du. You know, I don't know, whatever. So uv. So this times this. Remember, this doesn't have to be integrated. At this point, you can kind of clean her up as you write it. Does that make sense what I'm saying? It's done. So uv would be like negative ln of x over x. Does that make sense?
Mhm.
So negative ln of x over x minus the integral. And what's v? Well, negative x to negative 1, and then du. Okay. So what do I know about this minus? It can become positive because of this negative. And when I multiply these two guys together, what do I get? 1 over x squared. Would you agree? 1 over x squared dx. Is 1 over x squared integratable?
Yes.
I made that up. I think that's a word.
Mhm.
Yeah, I can do that. So 1 over x squared is really x to the negative 2, right? So bringing this down to the right, I'm going to start writing up the side of my paper just to make you feel good. And then x to the negative 1 over negative 1, right? I just integrated. No plus c, right? Why? Because I have a 1 and an e.
Mhm.
And then I'm going to take, no, I'm just kidding. I have to start cleaning up. It wants the exact value, right? Yeah,
Yeah.
exact area.
Yeah. But
Yeah.
with the, could you make that positive negative again? Or
Yeah.
So I have negative ln of x over x minus 1 over x, basically,
Yep.
You
from
can
1 to e.
technically combine
You could combine
the
them.
same denominators, right?
You could if you wanted to,
So you
absolutely.
put negative ln of x minus 1 over x.
So I'm going to plug my e in first. Everybody cool with that? So I have negative ln of e over e minus 1 over e minus parenthesis. Plug in my 1 next. Negative ln of 1 over 1 minus 1 over 1. I think you guys are okay with this stuff. Am I wrong or right? Feeling
What's like the
comfortable?
absolute value of negative n?
So what's the ln of e? 1. Is everybody cool with that?
Yes.
So minus 1 over e minus 1 over e. And then what is ln of 1? 0. So 0 divided by anything, 0. 1 divided by 1 is 1. So 2 negatives make a positive. And so I've got negative 2 over e plus 1.
Negative 1 over e. Or you can't combine, yeah.
And you just leave it like that.
It just says use integration by by parts, not by parts, sorry. By parts. Not by pants, not by pants, nor by farts, by parts. To find.
I'm getting a little caught with the ln of 1. How do you resolve that is equal?
ln of 1 is 0.
And negative 0 is 0
L
over
is
1
0
is
is
0.
Yeah. And like this little guy here, it's got an e here. E to what power is 1? Well, it's a 0th power.
Or you can just do the ln of 1.
So ln of 0 is 1, you said?
ln of 0 does not exist.
Oh, okay. Well, that's right there.
It's undefined. Okay, let me slip down to something more
I mean,
recent.
if you're at all like confused about it, just plug it in your calculator and it'll give you the answer.
Yeah.
Lower numbers, using it correctly comes out to something that's
Look at 2006. Similar?
Check mark.
Yeah. Similar though. X 1/2 ln of x, minimum point, find the x coordinate, and find the area under the shaded region. But here it says 2 decimal places. So it doesn't want exact value.
Yeah.
Okay, that's a 9-point question. I mean, we'll do some more tomorrow.
Miss K,
Yeah.
are you going to have like a worksheet of past problems?
I can.
Because isn't our test going to be kind of like these problems?
Yeah.
Oh,
Yes.
They're going to be like the x coordinate problems?
Look at October, November 2007, please. Use integration by far.
To show that.
Yes, please. To do this equals this. Do you see the answer? Given the answer.
6ln.
So there's actually there's a place. Oh, that's a really good question. They want me to use integration by parts, but there's ln of x and dx.
So there's only
Holy
one.
cow.
Yeah.
This is one thing.
One, well, you could
That means
have.
ln of x is the derivative, right?
Let's do this one. Do we have time?
And you could have 1 as the
We
other.
got it.
3 minutes.
We got it. We can at least set it up.
Yeah.
So what do we have?
Because it says dx, we